This is the first experiment I'm going to be doing for the Physics 1010 class. As you can see, I've set up a horizontal ramp. I've marked it with tape. For every 25 centimeters, there will be an image on screen that will show you the measurements using a ruler to quickly verify that it is in 25 centimeters. Now, I was unable to find a ball to roll across the ramp, so instead I'm going to be using this cylindrical tin can. For this specific setup, I predicted the magnitude of the velocity is going to decrease as it goes from one mark to the next. We're going to be using a stopwatch to record the amount of time that it takes to cross from one mark to another. And using that information, we're going to calculate the average velocity of the tin can between each mark. And we'll use that to determine if the object was speeding up, slowing down, or moving at a constant velocity. So we're going to roll the can now, making sure to leave the hand before it rolls over. And as we can see, the ball slowed down as it moved across from one mark to the next. We can see this from the experiment as well as from the calculations that I'll be quickly flashing up on the screen. So our prediction matched the experiment. Now, because the tin can was slowing down as it moved across the ramp, that means that it had an acceleration. This acceleration was pointed in the opposite of the direction of the velocity. In other words, the object was accelerating backwards. This is because the object was moving forward and it was slowing down. This acceleration was caused by the frictional force between the tin can and the ramp. And because the object was decelerating, we know that there was a net force acting on the object. In other words, there was a non-zero net force acting in the opposite direction of motion or parallel to the acceleration. Now we are going to repeat the experiment, but this time we are going to increase the slope of the ramp. So instead of it being horizontal, it is now taller on one side than the other. Also, we are going to release the object instead of push it, since it should accelerate downwards. My prediction for this experiment is that the average velocity of the object is going to increase as it travels down the ramp. So we're going to roll the object now. And as we can see from the experimental data, as well as the calculations, the object's average velocity was in fact increasing. The results matched our prediction. Because the object's average velocity was increasing, that means that it was accelerating. Specifically, it was accelerating in the direction of motion or the direction of the velocity. Because it was accelerating, that means that it had a non-zero net force throughout its path. This experimental setup was the same that Galileo had in 1604. He investigated how an object moved over an inclined plane as well as a horizontal plane. Using his experiments, he determined that if it wasn't for the frictional force caused by the ramp, and if it wasn't from the gravitational force caused by the Earth, the object itself would be moving at a constant speed in a straight line. In other words, it would never stop. He determined that this was the case when he found that on an inclined ramp downwards, the object would be speeding up, and when on an inclined ramp upwards, the object would slow down. This, to him, that meant that there was some point in the between when the object would be moving at a constant speed, or when the object would not be accelerating.